All right, so in this journal 16 here, I have a practice test problem. So you're going to see this problem later on in your test. The only thing I've done is change the numbers around. So in this word problem here, it says that last week at MRS sold 25 pets. Some are cats, some are dogs. So maybe let's start underlining things that might be important, like these numerical values. So let's see here. Maybe 25 pets is important. They made $1,125. Dogs are sold at 75 and cats are sold at 25. How many dogs did Animal RS sell? So first off, I need to figure out like what I'm trying to find, and it looks like I'm trying to find how many dogs that this store is selling. So I need to start declaring variables. So maybe I'll make X here the number of dogs. Now, like we've done with a lot of the word problems, is we've created a 2x2, two equations, two variables. So I know it's not asking to look for the cat, but I might need to use another variable so I can structure my equation to solve for dogs. So I'm going to put y in as the number of cats. And then I have to create my two equation. The first equation I noticed is like, well, the dogs and the cats are being sold for these prices. So if I want to know how much they going to sell a piece, I can use 75 and relate it back to the number of dogs. Whereas 25, I can relate it back to the number of cats. So what I'm going to do here is I'm going to take 75 and multiply it by X, which is the number of dogs. So if I'm multiplying price by the number of dogs sold, I can get how much money I made from just selling dogs. Same thing with cats. If I multiply cats, the $25 by the number of cats, I'm going to get how much money I made from selling the cats. So this is going to be $75 times X and $25 times Y. And when I add them up, I should get the total that I made, which is $1,125. Also, I noticed that I have 25 pets total. So that's telling me if I add two things, I should get 25. Well, that also tells me, well, I have X as the number of dogs and Y as the number of cats. If I were to add X and Y, I should get 25. And so now that I have a complete two equations, I can try to use elimination because it is in standard form. So if I were to use elimination, perhaps let's cancel out the Y, since not only are they smaller coefficient, but they also, when I look at it, we're trying to find X, right? So I want the X's. I kind of want to cancel out the Y, so I am left with X's to find the dogs. So in this case, I'm going to try to cancel out the Y's. So I need both of these Y's to be, well, that's 25, that's 1. So I can make them both be 25 if I multiply the bottom one by negative 25, right? So that way that this one would be positive, this one would be negative. So I'm going to distribute that in, but the first equation, I don't multiply anything, so I'll bring it down the way it is. Second equation, if I multiply by negative 25, I get negative 25x, negative 25y, and negative 25 times 25 is going to give me negative 625. And so when I add these two, I already noticed that my y's cancel. If I add up my x's, I get 50x equals 1,125 added with negative 625 is 500. So if I divide by 50, x is equal to 10. So I get x equals 10, but I need to ask myself, okay, what is this 10 here? What is this x? Well, that's the number of dogs. So I know that there are 10 dogs here that they sold. And I know that they just asked for dogs, but if they were to ask for cats, right? You could plug 10 into one of these equations, solve for y, or you could just think about it. You have 25 pets total, 10 of them are dogs. So that means, well, if you subtract 10 from 25, you get 15. So 15 here are actually cats. And that's how I can quickly do the math. All right, so let's talk about graphing for today. I'm going to give you some direction on how we graph inequality, systems of inequalities. Okay, so here these steps might look very familiar. When we were graphing linear systems of equalities, we were using these symbols here with the inequality signs, right? And then you might remember me telling you like, oh, a inequality that has an equal sign is a solid line. So whenever you see something with an equal sign inequality, use a solid line. Dashed lines are the ones without an equal sign. And I also like to mention when you are graphing, you want to make sure the y is by itself. So that way you know what your slope is, your m, and your b, your intercept, your y-intercept. So when you get y by itself, you can tell what the slope is and what the y-intercept is. Also on here, we do some shading, right? Whenever you want to shade above, that's when y is greater than the equation. When y is less than the equation, that's when you want to shade below. And so here's the thing. I'm going to give you at least two equations that you have to graph and shade. And so in this case, when you do that, you're going to find the intersection of where all the colors meet up. So let's see how that's played out using examples from the packet. So let's take a look at our packets 3, page 7. So turn to page 7 of your packet. All right, so this is the packet on page 7. I'm doing problem number 1, as you can tell. And so we have to graph the system of equation, which means that we're given two equations, and these are linear inequalities, so you can see the inequality signs. So the first thing I'm going to graph is the y greater than 5. Well, I know that when y is by itself, it's this horizontal line. And if you don't know that, what you could do first is, well, it's y is greater than 5, right? So a y value is located on the y-axis. And 5 is right here, so I'm going to plot that. So this is going to be my first equation, and this will be my second. So I'm going to do this in green. And then the thing is, when you plot it, it needs to intersect the y equation here. So notice how it's going to be a horizontal line, because this line right here represents all of the y values that are 5. And so when I draw this line, this needs to be a dashed line, because notice how the inequality doesn't have an equal sign. So this is going to be a dashed line. Let me go get my highlighter here. So it says that y here is greater than 5. Well, in that case, when you look at the y-axis, right, y values that are greater are over here. They're going to be above this line. So I need to shade above this line. Now we're going to figure out the second equation. So I'm done with the first equation. Second equation is x is less than 7. So if you don't know that this here, x, when it's by itself and just a number, it is a vertical line. But if you didn't know that, all you got to do is go to the x-axis, plot your x equals 7. So if x equals 7 is right here, it is a solid line. By looking at the inequality, there is an equal sign. And so where x is always 7 is this strip here. This is where all of the 7s are for x. So if I were to draw a solid line, it looks kind of like this. And then I have to figure out my shading. And so the shading part, when I look at it, these are, x is less than 7. So the shading part represents x. So you want to shade on the left-hand side. These values on this side are less than 7, whereas anything to the right is going to be greater than 7. So I'm going to shade this part. And what I'm doing is, as I'm shading it, I'm looking for where do green and pink meet up. And you guys might be able to tell that the intersection of these two colors are right here. So that's where the two shaded regions meet up. So this here is our intersection. So for systems of inequalities, what you're trying to do is you're trying to find the area on the graph that where the two shaded regions meet up, or the two inequalities meet up. So it's not like an intersection point, it's an intersection area. Okay, so we're going to do a few more. I want you to try out number 3 with me. So in this problem here, I'm going to first label them. So this will be my first equation, and then my second. And so the first equation is very similar to what we were doing before. This is y greater than or equal to -1. So because it's y by itself, I'm going to have a horizontal line. So I go to the y-axis at -1. And this here is a solid line. So I'm going to draw a solid line at -1. Notice how all the y values here are -1. This is when y equals -1. And I have to shade, well, y is greater than -1, so I want to shade above this line. Since these values here are where y's are bigger than -1. And then for the other line, the other equation, notice how the y is not by itself, right? So in this case, I need to get this y by itself, so I'm going to start by moving over the 5x. So if I subtract over the 5x, that cancels. I have 3y that comes down. Inequality drops down. Then I have -5x minus 9. So I brought down the 5x and the 9. If I divide by 3, the 3's cancel. So I have y is greater than. Make sure you divide both of the terms here by 3. Now, you can divide -5 with 3 in the calculator and get a decimal number, but I don't want you to do that because I want you to realize that this here is your x, right? So this number in front of x represents the slope. You want to keep that as a fraction. So 5 and 3 don't divide nicely, so keep it as a fraction. So just -5 over 3. And then 9 divided by 3, or -9 divided by 3 is -3. And so here I have my equation that I need to graph. So I can tell that the intercept here is -3. So if I go down to right here, that's where y equals -3. The slope here is -5, 3. So that means down 5, down 5, 1, 2, 3, 4, 5. And then over 3, 1, 2, 3. So right there, and this needs a solid line. So I'm going to draw a solid line. And then I'm going to grab my highlighter and I need to do the shading. So it does say that y here is bigger. So notice that if this is the line, right, and this is the y-axis, well, y values that are bigger are going to be on this side of the y-axis, right? So that means that I'm on this side of the line, so I want to shade this part of this side of the line. So that's going to be above the line. Oh, I forgot to grab my highlighter. Oh, well. So looking at this here, it looks like the intersection of the two shaded regions are right here. Kind of looks like a trapezoid. And so there we have our intersection. Let's do one more together. Number 6 is the most challenging one. Since the equation on number 6, either of them don't have y by itself, so we'll need to solve for both of them, but we can do it. So here's number 6. Again, I'm going to label my equations here. So I'm going to write my equations down here. Let me get this out of the way. All right, so for my first equation here that I'm wanting to graph, I need to get the y by itself. So I'm going to rewrite the equation here so I can work it out. And so I need to get y by itself, so I need to move over the 4x. So I have to subtract over the 4x to get rid of it. So that cancels. I have -3y, -4x plus 9. And so if I am trying to get the y by itself, I need to now go ahead and divide by -3. But hold up, I'm dividing by a negative number. So when I divide by -3, this cancels, y drops down, but remember, when you divide by a negative number, the sign switch. So the sign switch, and then -4 divided by -3, they're two negative numbers, so that becomes a positive number. And I'm just going to keep it as a fraction since I know this is the slope. And then 9 divided by -3 gives me -3. And there is my equation. And so if I wanted to graph this, well, I have to go to y -3, which is right here. And then my slope says to go up 4 over 3. So I'm going to go up 4 over 3, which is right here, and plot my point. And based off of this inequality, I need a dashed line, and I need a shade above since y is greater. So I'm going to make a dashed line, and I need a shade above this line, so it's going to be this section here if I want a shade above it, because y here is greater. Also notice that the y values are bigger on the side of the line. So I'm going to shade this region right here. Okay, now for our second equation, the 2 here, the second equation, is not by itself either, so I'm going to rewrite it and work it out over on this side. So just like before, I'm trying to get the y by itself, so I need to move over the x. So I'm going to subtract over the x. That cancels, so I have 3y is greater than -x plus 6. So these are not like terms, so you just want to bring it down the way it is. So from here, I'm going to divide by 3. Divide by 3. That cancels, so I have y is greater than, okay, you see how this x here is a negative? And so in that case, that this really is a -1x dividing by 3. So I'm going to write this as -1 over 3, because that is going to be my slope, so I'm going to keep that as a fraction. 6 divided by 3 gives me 2. And so here is my equation that I need to graph. So the intercept here is going to be at 2, which is right here. And then the slope here says -1 over 3, so I have to go down 1 over 3. And from there, I need a dashed line, it looks like, because of the inequality. And so now I'm going to do my shading. I also noticed that y here is bigger than this equation. So if y is bigger, that means I want to shade above this line. So I'm going to shade above this line. And so it looks like my intersection here is here, right? So notice how the green shows up and the pink. And so there we have our intersection. All right, so hopefully this helps you have an idea of how we do systems of inequalities on the graph. So try out the other 3 that are on this page. If you ever need help, let me know. Okay, that's it for this journal. Have a great day, guys.